Hi, and welcome to another Hopper video. Hopper is a modern curly brace and semicolon language, a bit like Java and C#, but without the classes, and designed to run on small devices. You can see more about this in the other playlists. This video is about how to flash your program onto your Raspberry Pi Pico, your Hopper program onto the Raspberry Pi Pico. In the earlier Getting Started videos, I explained how to set up your development environment on Windows, and how to get the runtime onto your Raspberry Pi Pico. I'll put the links at the end of this video to those videos. This is how to get your program onto the device. So let's edit our sample. Oops, a typo. There we go. This is your usual built-in LED blink program. I built it. The bottom of the screen it's built. This was F7 I pressed, and if I press F5 I'll launch the debugger. If I press F5 again it'll run this in the debugger, and if you look at the Pi there, we've got a blinky light flashing over there. If I Control C in the debugger it'll break and the blinky light will stop flashing. And then, just for clarity, I'll exit out of this development environment, and then I'll go and power cycle the Pi Pico. And you can see that it's blinking again. When it initially powers up, it blinks rapidly, and that is just the little flicker is to indicate that initialization has happened. So you got some feedback from your device that Hopper runtime initialization has happened. But now it's running the blink program, which is obviously in the flash because I took the power off and put it back, and it's still there. So how does it work? It'll take when you run the debugger, it uploads the program you want to debug to the device, and then that program will still be there the next time you power cycle. You can also do it manually from the monitor in the console here. So I could also just do load blink here, and it says successfully uploaded bin blink hexi, and it stopped it. But if I power cycle, we should get the blink happening again. There it is. Yeah. Okay. How does it work? Well, I've got a test program I can show that illustrates how this works. I implemented it using the Hopper. Hopper has two system units called directory, a couple of directory APIs. They look very similar to C#, and file APIs. Also, again, they look very similar to C#. I'll do other videos under language, which will be not be platform specific, which will explain these APIs because they do behave slightly differently. They're not identical. And then this little test program walks from the root, calls recursively, and walks through and prints out the directory structure with some indentation happening on every loop, and it also prints out a list of files in each folder. Let's try and run it. So F7 to build, F5 to launch the debugger, F5 again to run. So now we can see up there, this is the directory in the flash on the Raspberry Pi Pico. It has a bin folder and a temp folder. Inside the bin folder is something called auto.hexi, and that is your current program. So you can have other things in here. You can put your own data on the flash drive, on this current Pico that I have here. The memory space the flash space for programs is about 1 gig, and the flash space for is it 1 meg or 1 gig? 1 meg, and 1 meg for the file system, which is it's implemented using littlefs. Okay, if I exit out of here and if you code gen test, it says 419 bytes. So this is how big in bytes that test program was. So if we go back to that debugger, and now that 419 makes sense. It's the size of the executable. So that's the executable that it transferred across. Anyway, that's how you get your executable onto your Raspberry Pi Pico. That's simple.